Hi, we are Luscious Bread Skewer, and today we chose to solve the Safer Traveling Challenge by Honda. To increase user safety in vehicles, we decided to tackle the issue of cars flipping over after major accidents. There was an incident several months ago in which someone had been in a car accident that resulted in the car being flipped. Furthermore, water was getting in the vehicle and no one could get out. Luckily, they had an Apple Watch that allowed them to call 911, and the help dispatched ended up saving her life. To prevent events like that from happening, we decided to create an invention that would automatically detect whether the car is upside down and sound an SOS signal to alert nearby people for help. In the future, an automated call to the authorities would also be a feature, while being able to send them location information.
To prototype this idea, we used an Arduino Uno R3 with the MPU 6050 accelerometer and gyroscope sensor. The gyroscope measures the rotational velocity of the angular position over time along the X, Y, and Z axis. The outputs for the gyroscope are in degrees per second, so to get the angular position, we needed to integrate the angular velocity. The sensor can also measure gravitational acceleration along the three axes, and using some trigonometry, we can calculate the angle at which the sensor is positioned. Using this data, we can get extremely accurate information about the sensor orientation. We use this data to determine whether the vehicle is upside down or not. For this code, we use C++ and Arduino IDE to test our creation. The wire.h library was used for IC2 communication and defining variables needed for storing the data.
Using the sensor data, the roll, pitch, and yaw were calculated to determine whether the sensor was upside down from its original position. To create sound, a speaker was attached as well as an SD card module to hold the .wave sound file. The sound was also amplified using an LM389 operational amplifier circuit. The circuitry also included a filter that consists of a 1 microfarad capacitor in parallel with the output to help eliminate high-frequency noise. The TMR-PCM.h library was used for the asynchronous playback of sound files. Using that library, a sound file is played and repeated whenever a car is detected to be flipped over. Once the car is right side up, the sound is terminated.